In this example, we'll use two client machines. Client 1 will be logged in as good user, and client 2 will be logged in as bad user. Good user represents an administrative user who should have full privileges to the machine, and client 2 represents an administrative user who should have reduced privileges into the machine. Both users, good user and bad user, are administrators on the local machines, and the clients are built identically. We will cover three specific examples of privilege de-escalation, briefly discuss how they can be expanded, and then look at the policy changes that were done to complete this particular demonstration. The first example will show how a specific application can be restricted based on the user executing the application. For this example, we're going to use the command shell built into Windows. We've assigned privileges so that good user can run the command shell, but that bad user is going to be denied from executing the application. And keep in mind, this can be assigned to any application running on the machine. So in client 1, we're going to execute the command shell who's logged in as good user. And from here, we're prompted with the command shell, and you can see we are in fact logged in as good user. As we move over to client 2, who's logged in as bad user, this again is the administrator who has his privileges restricted, we're going to try to run the exact same command, the command line. Here you see we receive an error message stating that we do not have privileges. Basically what we've done is we've assigned that cmd.exe can be executed by only the good user on this machine, or we can also specify that to a particular group, and these can be either local users, Active Directory users, or local groups, or Active Directory groups. For the next example, we're going to leverage the Telnet application, telnet.exe. For this example, let's assume that corporate policy states that Telnet should never be allowed to run across our Windows machines or our Unix Linux machines. So for this example, we've set Telnet to what we refer to as no privileges. So now it doesn't matter who initiates the Telnet application, be it the good user, bad user, an administrative user, a regular end user, the application is not going to be allowed to execute on any machine protected by critical system protection. To demonstrate this, we're logged in again to client 1 as good user, and we'll attempt to run the Telnet application. You see we receive a permission denied message. We'll go and do the same thing on client 2 as bad user. And again, keep in mind these are administrative users on each of these client machines. Again, as bad user, we receive the same permission denied message. For this last example around privilege de-escalation, we're going to show how we can actually take not only an application, but a piece of data and restrict which applications and which users can access this particular data. This data could be a text file, it could be an Excel spreadsheet, it could even be a database. And the implications of this is this now allows you to lock down critical data and determine exactly who and what can access that data. So take into account a database, being able to block out a particular data store so that only Microsoft SQL or only Oracle has privileges to go touch that data store. A user coming in and trying to request that information directly would be denied. For this example, critical system protection locks down the host file on a Windows machine by default. What we're going to go and set up is an example where we're going to keep that host file locked down, but we're going to allow good user to use WordPad to open this file, but bad user will be denied no matter what application they try using. So for client 1, we're going to go ahead and launch the WordPad application. We're going to locate the host file. And we actually allow the file to be opened and read, but we don't allow any modifications to it. So for example here, I'm just going to add an additional line. And now that we're good user, I'm going to be allowed to make this save, and I've just now successfully saved the file. But now when I go over to client 2 and bad user, we're going to do the exact same steps. So again, we're still, because of the way CSP is set up right now, we're still going to be able to be allowed to see the file. But as we go in here and try to add the exact same line, and now try to save the file, if we try to make any modifications to this file, we'll get a permissions denied message. So these examples can then be expanded. So we can really take into account any application or any service running on your Windows, Unix, or Linux server or workstation. So some other Windows examples. We could use this same capability to lock down the Microsoft Management Console, the services screen, the event viewer, or maybe you want some users to be able to log into the event viewer, for example, good user, but not bad user, or maybe not your end users. We could lock these applications and these services and these management consoles down in much the same way that we just saw here with the command line, Telnet, and even the host file. Additionally, we could take into things like the net commands, or even something as trivial as Internet Explorer, allowing Internet Explorer to launch for everyone, for no one, only certain users, or only certain groups of users. Another great use case is around change control, or more importantly, change control enforcement. So being able to go in and define that Altiris is your software deployment and patch deployment tool, and that nothing else has privileges to push out new software or new patches. We could restrict things like Windows Update. So if somebody went in and tried to manually run a Windows Update, that application would be denied, but anything coming in from the Altiris agent would be allowed. Basically, this allows you to define how your software runs, manages, and is updated. For those of you familiar with the prevention policy and critical system protection, let's take a look at what we did to accomplish these examples. Let's start off with the command shell. So first, we went under Global Policy Options. We went to Resource Lists. We selected No Access Resource List. And we essentially defined the executables that we wanted to make no access. What's happened up to this point is we've now said that the application, cmd.exe, can't be accessed anywhere on the system by anyone or anything, including the system itself. Now, in order to allow good user to access this particular file or application, we're going to go down to Interactive Program Options. We're going to go to Default Interactive Program Options. We're going to come in under Resource Lists and select Read Only Resources. We could also make this writable if we wanted to as well, but since it's a read-only application anyway, let's go ahead and make it read-only. Let's edit the entry that we put in. So here we see that we've allowed access to command.exe by Windows, and we've specified the user here. And again, this could be a local user, this could be an Active Directory user. We could also do the same for groups, both local and Active Directory groups. We can assign a name for the rule, what we'll see in the console when events are actually generated, and we can also put in comments. So we can specify why we entered this rule, or even what an analyst needs to do when they see this particular rule. Next, let's take a look at blocking telnet.exe. All we need to do here is go under Interactive Program Options, Alternate Privileged Lists, And we're going to expand the first option, specify interactive programs that should not start. This is referred to as programs with no privileges. And here we're going to simply enter the path to telnet.exe. As with the command shell, if we had wanted to, we could have actually taken into account username and group names as well that this should only apply to. And again, you can see we have the same ability to add a rule name and a comment. And for the last example, allowing the host file to be opened by good user using only WordPad. What we're going to do is start off under Interactive Program Options. Now keep in mind, the host file is already locked down with the strict policy built into Critical System Protection. So we're already, within the policy itself, going to make that file read-only. So what we need to do is go and open up privileges to that particular file so that WordPad can be used by a good user to make changes. To do this, we're going to move down to Default Interactive Program Options. We're going to come down to Resource Lists again. This time we're actually going to go to Writable Resource Lists. And we're going to choose the entry that we've entered here. So the first path under Resource, you can see here's where we specify the actual file, the host file. And then under Program Path is where we specify the program that we want to allow. Now if we wanted to allow all executables within a particular directory, we could replace WordPad with an asterisk. Same thing if we wanted to allow the host file or any other file in the Etsy directory, we could replace hosts with a star or with a star.txt or whatever we wanted to do. And now to specify that this only applies to good user, we also define good user here under username. And once again, this can apply to local users, AD users, local groups, or AD groups. And then we specify a rule name and a comment to go along with it. In summary for this session, we've now looked at locking down an application, restricting access to the application. We've also looked at locking down an application based on the user executing it. And we've also looked at locking down a piece of data and specifying which applications and which users can access that particular type of data. Again, keeping in mind, based on these examples, we can expand these to any application or any service running on a machine protected by Critical System Protection. Thank you.